A cone has a radius r and a height 8 centimeters. Show that the volume of the cone is 1/3 pi r square times 60 minus r, and show that the cone has a maximum volume when r equals 40. And the part C is find the maximum volume of the cone. So here the first part is simple enough. I show the volume of cone is 1/3 pi r square times 60 minus r. So we know the volume of a cone is pi r square h. 1/3 pi r square h, and therefore here we've been given r plus h is 60, so h would be 60 minus r, and so we can write the volume is 1/3 pi r square within brackets 60 minus r. And that's all that needs to be done really for part A. So that's done. The next is show that the volume of the cone has a maximum volume when r equals 40. So we have to do some work here. The first thing to do is to differentiate with respect to r, the volume. So we write the volume again, that is V equals 1/3 pi r square times 60 minus r. So therefore, differentiating with respect to r. Now why are we differentiating? Because we need to find the maximum volume, and the maximum volume will be when dv out of dr equals 0. The first derivative is 0. So we would do dv out of dr equals, so before that I need to break it down because I find it easier that way somehow. So if I write 1/3 pi r square times 60 minus 1/3 pi r cube, so then can write this as 3 times 20, so 20 pi r square minus 1/3 pi r cube. So I find this easier to differentiate. So then dv out of dr, I can write it as 40 pi r minus 3 times 1/3 pi r square. That equals 40 pi r minus pi r square. So for maximum volume, dv by dr is 0. So when volume is maximum, dv out of dr equals 0. So therefore you can say 40 pi r minus pi r square is 0, and if you are to take pi r outside bracket, then 40 minus r equals 0. Now r is obviously not equal 0, and neither is pi is not 0, so pi r is not equal 0, or we can say, because or r can be 0, I'm saying it's not equal to 0, but r could be 0, but then if r equals 0, this there is no cone. So then we say that r, I will say r not equal to 0 in this case, so then 40 minus r equals 0, and we get therefore r equals 40. Okay, so r equals 40. So then we have shown that when r is 40, but is it the maximum volume? We need to go do one more thing. That is, we need to do differentiate again, find the second derivative. So what we can do is we have we can do the so if I were to do d2v out of dr square, you see dv by dr is this 40 pi r minus pi r square. So I have to find that at r equals 40, what is d2v out of dr square, or the second derivative. So that let me do the second derivative first. It would be r with respect to r, so it would be 40 pi minus 2 pi r. Okay, now at r equals 40, d2v out of dr square, this is capital V mind you, so that would be 40 pi minus 2 times 40 is 80 pi, and that is minus 40 pi is less than 0, and we know that if the second derivative is less than 0, then you have the maximum point. So what I would write is therefore this is the maximum value is attained. So the maximum volume is attained at r is 40 because the second derivative is less than 0. So then we have shown that the cone has a maximum volume when r equals 40. Okay, so the third part is very simple, and all we have to do is find the maximum volume of the cone. So I can do it here. The third part, maximum volume, will just put r equals 40 in this in part A in the equation. So 1/3 pi r square, so times 40 square times 60 minus 40, and that is 40 square is 1600 multiplied by 20, so that's 3200. There's another 0. Am I right? 16, 1, 2. Yeah, that is right. And times 20. So 3 zeros. I always get the zeros wrong. So then 32,000 pi out of 3. So the answer, the maximum volume of the cone, would be 32 and then 1, 2, 3 zeros pi out of 3. And of course you write centimeter cube.